So let's assume then that we have a circle. Okay, with center O. And we have a tangent to the circle. Call it line L. Okay, let's say that the circle meets the line in point of tangency A. So that makes OA a radius. And as we know, OA then would be perpendicular to line L. Let's say we have a point C out here, just for reference. And we have a chord, AB, like such. And the question is, what is angle CAB? This angle here. What is that angle? And how can we relate that angle to the measure of arc AB? So just as we do so many times, what we're going to do here is draw a radius, OB. That will give us line segment OA is equal to line segment OB. Gives us an isosceles triangle. We know in an isosceles triangle that the base angles are equal. So we now have that angle BAO equals angle ABO. So this angle here is equal to that angle there. We know that OA is perpendicular to AC. So how can we start solving for angle CAB, which is what we're looking for? Well, we know that the angles of a triangle add up to 180 degrees. So we know that the angles of this isosceles triangle have got to add up to 180 degrees. So let's start adding up those angles. So we have angle AOB, which is the central angle, AOB, plus angle BAO plus angle ABO, all equal to 180 degrees. But we also know that angle BAO and ABO, these two angles, are the same because this is an isosceles triangle. So we can put in for ABO, BAO. So why don't we do that? So we have angle AOB plus 2 times the angle BAO equals 180 degrees. And we know also that angle AOB, the central angle, has the same measure as arc AB. So we can put in, for angle AOB, we can put in the measure of arc AB. So we have measure of arc AB plus 2 times the angle of BAO equals 180 degrees. Now we can solve this for BAO, and let's go ahead and do that. So we can subtract measure of AB from both sides. That now gives us 2 times the angle of BAO equals 180 minus the measure of angle, of arc AB, and now we can divide both sides by 2 to isolate angle BAO equals 180 minus the measure of arc AB divided by 2. So we have this intermediate result, which we will find helpful for us in a minute. In order to figure out how to use this result, though, we have to go back to our diagram and notice that angle BAO, which we've solved for, is this angle, the base angle of the triangle. And that angle plus BAC will give us 90 degrees because we know that there's a perpendicular here. So now we know that BAO plus BAC is equal to 90. So we have angle BAO plus angle BAC is equal to 90 degrees. We can now use both of these equations together to solve for angle BAO. So let's do that now. We know that, I'm sorry, to solve for angle BAC. Remember, it's BAC that we want. This was the angle we wanted, BAC. So now we'll use these two to solve for BAC. So what we will do is we will substitute BAO from the first one into the second. So where we have BAO here, we're going to put 180 minus the measure of arc AB divided by 2 plus angle BAC equals 90 degrees. And again, this is what we're interested in solving for, angle BAC. Let's now move things around a bit. We can subtract 180 minus measure of arc AB over 2 from both sides. Move this onto the right side. Let me redraw what we'll have when we do that. That will leave us with just angle BAC on the left. And then we will subtract this from the right side to give us equals 90 minus 180 minus measure of arc AB over 2. Okay, so this is our equation so far. 90, we can get a common denominator for 90 and this term by multiplying 90 by 2 and then dividing it by 2. So we have angle BAC equals 180 divided by 2 minus 180 minus measure of arc AB over 2. That means angle of BAC. We have one common denominator now, which is 2. We can subtract the numerators directly. We have 180, and then from 180 we are subtracting this term here, minus 180 minus measure of arc AB. That can be simplified to give us that angle BAC equals, well, 180 minus 180 is 0. 180 minus negative measure of arc AB is a positive measure of arc AB, so we end up with measure of arc AB over 2, or 1/2 times the measure of arc AB. So we end up with a formula telling us that angle BAC is 1/2 times the measure of arc AB. If we go back to our original drawing, what we'll see is that then what we're saying is that BAC equals 1/2 the measure of arc AB, and that is exactly what we had originally intended to prove. So we have proven part of our theorem. The rest of it follows because we also have to prove that angle, if we put a point here for reference, let's make this D. Okay, we also have to prove that angle BAD equals 1/2 of the measure of, and let's put another point here, E for reference for the major arc. We have to prove that angle BAD is equal to 1/2 of the measure of BEA. BEA, arc BEA. Well, we already know that minor arc AB is equal to 1/2 of the measure of AB. Okay, so we know that the measure of BEA has got to be 360 degrees minus the measure of BA, minor arc BA, because the total must add up to 360 degrees. So let us put now here, instead of measure of BEA, we can say that angle BAD is equal to 1/2 times 360 minus the measure of minor arc AB, since we know that the two of them have to add up to 360 degrees. Okay. Well, this gives us, this is the same thing as saying angle BAD is equal to 180, just distributing the 1/2 out here, distributing the half up there, minus 1/2 times the measure of arc AB. So we now have an expression for BAD in terms of measure of arc AB. But this on the right happens to be the same as 1/2 times 360 minus measure of arc AB, which is what we had above over here, which is what we set out to prove. We needed to prove that the BAD is going to be 1/2 of this arc, and that's basically what we have shown.